Hello and welcome to my presentation. This presentation is called Learn to Earn. My name is Anthony Goodwin. I have a Master's of Science in Education Research. This project was created January 24th, 2025. A little bit about me. My background is education research, and I focused on college and career readiness, studying how students transition from their formal secondary and primary education experience into the upper higher education or the workforce. I am currently an AI response analyst, which involves examining the quality of LLM or large language model responses and making suggestions and recommendations for how these models can improve. Okay, so the description of this project is this is my capstone for my Google Data Analytics certificate, which I've been working on for a month or so, maybe a little more now. And so for the capstone, they give the option to choose one of their provided data sets or go and find your own data set, which is a little more difficult because you have to develop your own business task, analyze your own chosen data set, and generate insights and produce the deliverables you decide. So it is a little more flexible because you have a little more control over the design of the project, which I appreciate. I love design. So I chose path B because I really wanted to see what it felt like to put myself in the shoes of a professional data analyst that has to go and find data sets to satisfy a unique problem that a business may be facing. So the data set that I chose came from Kaggle. It's a great site that was shown to us in our analytics course. And the original data set is owned by the U.S. Census Bureau, received or created around 1996, and I accessed it January 2025. So here's the adult income data set. It's pretty popular from what I saw, and the dependent variable that we'll be working with is income above and below $50,000. So I really wanted to find a data set that deals with students and success in some way, education levels, and how they're related to students' ability to construct vocational pathways in some way. So let's get into the actual business task, which is the problem that I had to create based on this data set, which is fun. I had to create a problem to try and solve with data. It was awesome. So I decided on a WHO, and the WHO was the Link, which is a startup college and career organization which helps students put together a vocational pathway based on their academic interest or their passions, whatever those might be. So they needed an education data analyst. What do you know? That's what I do. And what did they want exactly? Well, they needed descriptive insights to help them understand their potential customer base because they're a startup. So they need some data to tell them who they might be serving with their service. So they also needed some insights that could help shape their curriculum, how they could direct students with their curriculum. And that's what I came to solve. Some of the key metrics that came from this data set that would be useful to their problem were age, occupation, education level, and income. And we got to play around and see how these things are represented in the population and distribution, and then related with some more advanced statistical tests. So a little sub-story inside this bigger data story that we're telling here is that this idea came from a startup that I wanted to start shortly after I finished my master's in education research. So I thought it would be fun to see how a person starting a business like this might go about surveying the population and figuring out how to best serve it. The procedure for this presentation will largely mirror the process that I used to carry out the project itself, where I cleaned the data, I summarized the data to see what I was working with, analyzed it, ran some tests on the data with a more clean and refined version, and then generated some insights summatively based on everything that was discovered. And with this, I'll be making some recommendations and suggestions for how this business can best serve their population. Okay, let's go through the first step, the cleaning process of the data analysis process. So what I discovered early on is that I was dealing with these question mark values, which represented the nulls or the not available values that were scattered throughout various columns in the data set. And so I had to figure out what I was going to do with those so I could run some group statistics. And what I did was I used Python's Panda library to replace those values. And this just made it easier for later when I wanted to drop the NAs to run the more advanced tests. Okay, now moving into the summarize phase, now that our data is a little bit cleaned up, I wanted to get the range of our data and some group stats. So I ran some SQL queries, which was really fun. And what I decided to do is split the ages into groups And I went further to split those groups into their given income bracket. So we had the 17 to 50 below 50K a year and 17 to 50 above. And I did the same thing from 50 to 90 to get a good picture of the distribution. And what we found is that the 17 to 50 below 50K a year was quite overwhelmingly the majority of the data, followed by the greater than 50K for 17 to 50. Continuing with the group stats summary, I wanted to visualize the stratification of the age range and income groups a little more distinctly. So I plotted the income groups by age from this census. And as you can see on the x-axis there, the age range is from 17 to 90, from left to right. And what you're seeing on the y-axis going up is the total count for that age group. Now, the split in color represents the income bracket for that age group. So they're on the same line because you have the age group and then it's split by how much that age group makes in purple and how much that age group makes in gold. And our legend shows us there that our purple is below 50K a year and our gold is above 50K a year. What we see here is also what we witnessed with the SQL query numerically, that the distribution of individuals in the below 50,000 a year group is much more prevalent than the distribution of individuals in the above 50,000 a year group. And another trend we see here is consistent with data that measures these types of variables, and that is that as age increases from about the early 20s and on, you see that the distribution of individuals in the above 50,000 a year group grows. And then if you look closely towards late adulthood, so about 45 and forward, you can see that the bars do shrink, but that's the total count of individuals in that group itself. But the amount or the distribution in each group remains fairly balanced for the most part until you get into the later 60s. Continuing with the group statistics, I decided to plot the groups by their education level and their income bracket. So what you see here on the x-axis is their education levels provided by the dataset, and then moving up on the y-axis again, we've got the total count for each education level, and then in color, split by their income group. What you can see here is that for the high school grads, largely they fall into this less than 50,000. For bachelors, it's more of a 50-50, pretty close. It was 60-40 in the stats. And then for doctorate, we've got largely dominant in this over 50K a year. For some college, largely under 50K a year. And then if you look here, for professional school, very largely dominant in the above 50K a year. So it would be interesting to get a bigger sample to see how this distribution looks. But as you can see here, this is the most, and doctorate and professional school are the most dominant in the above 50K for their individual group. And then if you look here, master's is pretty similar to how bachelor's is distributed, where it's almost 50-50. Okay, now continuing with the group stats, this chart is very cool. It's got a lot of data, it's got a lot of things going on here, but let's figure out what we're looking at here. So what we see is each occupation and the distribution of the education level that is within each occupation. What we can see here is that for this pastel-ish blue high school grads, they largely make up this transport moving occupation here, the most prevalent there. And then if we look and see for bachelors, where are they the most prevalent? Here in the professional specialties, they're very prevalent, and same with executive and managerial, they're very prevalent there. So where are our some college individuals the most prevalent? Well, they've got a few groups here. They've got tech support, they've got protective services, they've got administrative and clerical, and some of those are not far behind, but you can see that they're pretty well distributed throughout all of the jobs. That's our some college group. And then if we look for those that have master's degrees, what we see is master's degrees are the most dominant here in professional specialties. That's where they're most distributed. So looking at this a little more summatively, what we can see is that those with higher ed or further vocational training end up in this section. We've got our professional school trainees here, our masters, our doctorate, and our bachelor's here. And it's similar here in our executive managerial occupations, right up here. Now that we looked at occupation, let's look at the occupations by their income brackets. So what we see on the x-axis is the name of the occupational group, and then going up on the y is the total count of individuals that fall into each group, and this time the color splits them by their income bracket. So what you can notice here is that less than 50K is quite dominant throughout all of the distribution. However, if you look at executive and managerial, has a more even and balanced distribution, and the professional specialty as well has more positions or distribution in the greater than 50,000 a year. So this leads us to the question, like, why are there so many jobs that make below 50K? How do I get into this group here? How do I get there? That's the question we're going to try and answer. Okay, so moving forward with the analyze phase of our data analysis process. To satisfy the business task portion of providing insights that could help shape curriculum and guide students, what I wanted to do was check how influential various variables were on the income variable. So I took the opportunity to learn some Python code, and what this code here does is it maps the variables that have text as the values. As you see here, the income variable has below 50K and above 50K text, which we can't run tests on. So I had to use the Python code to code each variable into its own separate column, which then we could run tests on and find out how the variables move together and how influential they are on one another. Now that I had these new columns, there was still one more step to making sure that the data frame was ready for the tests. I had to get rid of those NA values that earlier we plugged into the data set using the pandas library. And as you can see here, these NaN values that we used and allowed to be included in the group statistics from earlier. So here's the Python code that we used to drop all those NAs that we created. And as you can see here, we calculated all of the null values that were dropped from the set, which resulted in taking out 6,465 observations, which left us with 42,377. And we started with 48,842. So that was about 13% of the data that we got rid of, which is okay. The first type of test I decided to run was a correlation. Now what you're looking at here is a correlation heat map, and what this shows us is it's a broad sweeping look at if variables are interacting or if there are relationships. And so we've got our heat meter over here, and moving up towards the red, that shows a positive relationship, meaning that they're moving together in the same direction. And then we've got our negative relationships or inverse relationships where they're moving in opposite directions, but there is a relationship between them. So now we've also got our perfect correlation diagonal here, and what that shows is when a variable is interacting with itself. So we've got ednum here and ednum here, and it's a perfect correlation because it moves in synchronicity with itself. It changes with itself. So if we look at income and educational num, we've got moving up the heat meter, moving in the same direction, some kind of interaction. It's a small number. And then also age and income, we've got some weak numbers, but there is some kind of interaction, hours per week and income. All right, and then gender and income, there is some kind of interaction happening here. Now moving forward, I wanted to take a more targeted approach to see how individual and groups of factors influence change in our income variable. So I took the opportunity to learn some more Python. I used the stats model API to run a linear regression. So what we see here are the different groups of independent variables that I tested. I ran this lower one first. When I tested the model, these were not included, only these two. All right, and then obviously our dependent variable here, income. And it gets loaded into the model here to see how well it fits together. Basically to see how much these two variables are influencing our dependent variable. and then we print out the summary, and we're going to take a look at that. And here are the results of our linear regression test. We've got the summary table printed out by the stats model API. It's very pretty looking. We've got our age variable down here. There is a restriction because of the fact that our income variable is a binary value between 0 and 1, so these values will be a little smaller. However, they do show us that as these increase, our dependent variable, our income, also increases. But again, there's a restriction there because it is a binary 0-1 value. All right, but there's a better test that we will look at after this to assess that. Now, looking at our R value, it shows that this current model, these independent variables account for 16.1% of the change in our income variable, which is cool. And we've got some huge t values here, meaning that the strength or the magnitude of these relationships is strong, and we can go about that assumption with great certainty based on these p-values. Now, looking at version 2 of our linear regression test, I decided to throw all of the variables at the model and see what we would get. And if you see this R value here, this model accounts for 21.8% of the change in our income variable. And again, remember these small coefficients restricted by the binary income variable. Still some big T values though here for educational num, age, and even gender here. So gender playing a part, and hours per week playing a part in the change of our income variable. And lastly, I decided to run a test that's a little more appropriate for a dependent variable that has binary values. So remember, our income variable has 0 and 1 as its values. So this test, a logistical regression test, is much better at looking at the probabilities of a person moving from below 50,000 to above 50,000. So looking at our R value, you see that this model is a little bit better fit than our linear regression test, accounting for 22.41% of the variation. So that's all these factors here together, and those are in relation to the probability of a person moving from the below 50,000 to above 50,000 a year. So we have some significant certainty here that these relationships, these probabilities, are significant. Now, looking at our coefficients, you see they are a little bit bigger. That's our better model fit, but they do mean something a little different. So let's take a look at what those mean. So let's take a look at gender here. You see, that's the biggest number in our odds ratio list. What does that mean? So what this means that as our individual moves from 0, female, as we coded it, to male, 1, as we coded it, their odds of making above $50,000 a year increase quite a bit. That's the most impactful number there. And then looking at educational num as the next most impactful factor on that probability of moving up. And then also race, you see that there. So any of these numbers that are above 1 mean that they increase the probability that a person will move from below 50,000 to above 50,000 based on that factor. Now there's one more number I want to look at and discuss as we close out, because this number here, it tells us what the base probability of a person moving from below 50,000 to above 50,000 would be. And that's a very low number. So what that tells us is that without all of these other factors here, a person's chances of going from the below 50,000 to above 50,000 bracket is minimal, quite low. So we're going to discuss that next. And with all of that, we made it to the discussion. Wait, what was the point of all of this? Okay, let's tie it all together by remembering our business task, which was to provide our hypothetical career pathways organization with some general descriptive insights about the population that they might serve with their pathways service, and to also provide some insights that might guide their curriculum and help them best serve their potential customer base. As we just saw, the probability of moving into the group over 50,000 a year is pretty low, which is discouraging. That could be discouraging to students, and the Pathways organization can inform students that this is the distribution. However, there are ways that you can increase your chances of moving from that below $50,000 a year to that above $50,000 a year bracket. And that's by magically aging. So as you age, your money just magically increases. I'm kidding. No. The Pathways organization can help their students understand that as they age, if they are focused on increasing their education level, and remember that education level implies skills. So if the students know to target those professional specialties that have certain skills that they're interested in gaining, they are more likely to move themselves into that above $50,000 a year bracket. So if the clients are oriented to the types of skills that are required for the jobs that they're interested in, people can self-study in the correct direction, or they can acquire the correct certificates that they need to move in the direction they want to go, and then help them focus on building their portfolios to showcase those skills. And consider that the professional specialty category as an occupation in our data set, it encompasses many different specialties. So a good direction that the Pathways organization can use for their clients would be to guide them in the direction of generalizable skills that have high value, that are making over that 50,000 a year. So if they gain a cluster of those generalizable skills from various professional specialties, their probabilities increase even more. And that's another study for another time, to be continued. Now, to make sure we're checking all the boxes, let's briefly discuss the limitations of this data analysis. So if you didn't know, I am not a trained statistician yet, but I am having lots of fun discovering all of the tools that are available at my disposal. And also, this data set is pretty old, from 1996. However, some of the reading that I did said that these patterns do persist over time. And for coding, I had to rely on a lot of external help from Stack Overflow and various AI models. I was cross-validating the code, and they can correct each other, which is quite fascinating to see. Now, the income data was categorical. It only had 2 categories, so it's hard to detect much variation with such a limitation on the categories available to us to analyze. And that's pretty much it. Thank you if you watched all the way to the thank you slide.